Hi all, my name is Lizbeth Fernandez, and today I'll be going over our PLSQL program that basically generates prime numbers. And I'll be going over the program right now. So in this program generates a 6 by 6 symmetric matrix filled with random prime numbers. And so let's start with the declarations. We first define a collection type called prime underscore tab, which stores integers. Then we create a variable g underscore primes and initialize it with a list of prime numbers from 2 up to 199, as you can see on the screen. This gives the program a pool of possible random primes to choose from. And then we also define two more types. As you can see, we define two different matrix types. So we define row underscore t, which is an associative array that will store one row of numbers, and mat underscore t is an associative array of those rows. So together they'll act as a 2D matrix. We also declare n as a constant with value 6, representing the size of our matrix, since our matrix will be a 6 by 6. And m will be our main matrix variable, and ij and idx are loop and helper variables. So overall, this section just sets up the data structures needed to create and store um, random symmetric matrix. And then we'll go on to the procedure aspect of this program. So the procedure ensure underscore role row takes a row index as input and checks whether that row already exists in the matrix. Since associative arrays in PLSQL are sparse, meaning that they don't automatically create elements, we have to make sure each row is initialized before we use it. So if this part right here is is not existing, the procedure creates it as an empty row. It's a small helper routine, but it basically prevents runtime errors when we start filling in the matrix later. And now we'll be moving on to the function aspect of the program. Um, so ran underscore prime basically returns random prime numbers from our list. Inside the function, we use dbms random value, and this basically gets a random number between 1 and the number of primes that we have. We then use trunc here to convert the value into a whole number, store it into IDX here, and it uses the index to pick one random element from G primes from the table. So every time we call rand underscore prime, we get one random prime from the list, as we saw in the first slide, and we use this function repeatedly to fill the cells of the 6 by 6 matrix that we are creating. And now let's take a look at the core logic of the program, which is building the matrix. So first we loop through all the values of I from 1 to n and ensure row to make sure all rows exist. This sets an empty 6 by 6 structure. Then we use nested loops to fill the matrix. The outer loop runs through the rows and the inner loop runs from I to n. So there's two loops in here. So for each pair ij, we generate a random prime using rand underscore j and assign it to mij. To make the matrix symmetric, we copy that same value into the mirror position mji. So mij and mji. That's what the line if and then does. So if you imagine this as a grid, we only fill the upper triangle of the matrix and then mirror it to the lower triangle. So let's say it's like 1, 2, 3 going down, then it's 1, 2, 3 across as well. So finally, the program prints out the matrix. As you can see here, this is the output of the matrix. We start by printing out the line generate prime matrix, and this basically will print that out, and then following will be the matrix below it. Inside another loop, we go through all columns, convert each number to text, and then use LPAD right here to make sure the columns line up neatly. After finishing each row, we print it using DMS output dot put line. When you run the program, you'll see a 6 by 6 grid of random prime numbers. Every run will look different unless you fix the random seed. So there's not really um, a one correct answer to this because you'll always be receiving different 6 by 6 matrices every time you run it. And right here, you can see example of the final output. So it'll first generate the return variable generated prime matrix, and then it'll print out the matrix. And that's all. Thank you guys.